In 41 through 43, simplify the given expression. Cite a property from 6.2.2 for every step. Here we have A intersection, parentheses, parentheses, B union, A complement, and parentheses, intersection, B complement, and parentheses. Now, the first thing I notice is that these two operations are different, which makes it very tempting to distribute this expression B complement to both of these terms. But we're not allowed to do that. If you remember our video, if you remember a couple videos ago from problem 29 of the same section, we talked about how we're not allowed to distribute from the right. So the first thing that we're going to actually end up doing here is setting up the distributive property by swapping these two expressions using the commutative law. You're allowed to swap expressions here. So our expression here is equal to A intersection B complement intersection B union A complement by the commutative laws. And now we can distribute this B complement to both of these terms using the distributive laws. And that's how that expression would simplify. And this is by the distributive laws. Okay, the next thing that I notice is here we have a B complement intersection B, which according to this law here, the complement laws, if you intersect a set with its complement, you get the empty set. So let's replace that section with the empty set, and we'll cite the complement laws here. So this will be the empty set union B complement union A complement, and that is by the complement laws. Now from here, I notice we have an empty set union something, and if we ever union with the empty set, then nothing happens. If you include a set with nothing, then you're not including anything additional. So it's the same thing as A intersection. And then now that we're getting rid of this portion, we don't need two sets of parentheses. So I'll just write this as B complement union A complement. And that's by the identity laws. Now we have two different operations, one inside the parentheses, one outside the parentheses, which makes this very tempting for the distributive law again. And since we're distributing from the left, we're allowed to do that. I'm going to distribute this A intersect to both of these expressions here. So this becomes A intersection B complement union A intersection A complement by the distributive laws. And again, notice what the distributive law says here. It says that we can take an A intersection and distribute it to the B and the C here to get two sets of parentheses, which is what we have here. Now we have another A intersection A complement, which by the complement laws can be simplified to the empty set. So this is A intersection B complement union the empty set by the complement laws. Now we have another union the empty set. If you union the empty set, then by the identity laws, that doesn't really do anything. So this simplifies to just A intersection B complement by the identity laws. And this is the exact format as the set difference law. So we can simplify this to just A minus B by the set difference law. So that means our original expression here is just A minus B. It's a very weird way of writing A minus B. But according to these set identities, we can simplify this to A minus B to show that it actually does equal A minus B. Anyways, this is how we simplify that expression to A minus B. Thanks everyone, and I'll see you in the next video.